So let me start the lecture series. Let's just start the lecture series. In this lecture series, we are going to see today. Uh, we are going to see today. So basically, this is the interview questions for experienced person first of all, and I would like to tell you that these are the questions are very important questions for those who are like going to attend some kind of experience, who has some experience of 1 or 2 years, or let's say 6 months. So if I'm like going to tell you everything properly, and we will discuss and we will try to make this session very interactive. So if you guys have some kinds of doubts or anything, that you can directly mail me, or you can uh, comment me as well. So that would both will work. So let's just start. First of all, the most important question that what I found that after my lots of research, that what I found that the Q learning. So Q learning is nothing but a model-free learning policy that choose the best course uh, of an action in an environment, depending on where in the environment the agent is an entity that makes a decision, enables AI to be put into the action. So basically, Q learning is something that is a decision-based thing. Like, we hire an agent, and agent can do something for our work according to our requirement. Let's say like there are a number of examples you can consider where the agent is required. So agent will take a better decision according to our requirement. And of course, like you can say, make a decision and enable AI to put into the model. Extent, sorry, model free learning policy means that the nature and prediction of the environment to learn and move forward. Yes, that's true. It does not reward a system to learn. It uses the trial and error method instead. Okay. So what is the meaning of trial and error method? Like, it will always make a mistake and will learn from his mistake, right? So there's a possibility that it will. The model's goal is to determine the optimum course of action given the current situation. To accomplish this, it may devise its own set of rules, or act outside of the policy that has been established for it to obey. This means there is not a real need for a policy, which is why it is called a policy. The agent's experience is stepped in the Q table in Q learning, and the valuing table indicates the long-term reward value of executing a certain action in a specific condition. The Q learning algorithm, according to the Q table, can instruct the Q agent the action to take in a given situation to maximize the predicted reward. What is the difference between a strong AI and weak AI? Strong AI is a theoretical form of AI, right? And weak AI called a narrow AI, or AI with limited functionality. It refers to building a machine with complex algorithm, and you can say like it does not show the entire range of human capability, but it show the entire like it's develop the like ability, or you can say it is like equal to almost equal to humans. So strong AI is like a very, you can say like advanced AI, but we can say there is no any like strong machine AI exist, like there is no any such human exist in real, right? So that is a problem. Okay, which assessment is used to test the intelligence of a machine? Okay, the Turing test is used to determine whether or not machine is capable of thinking like a human. It was developed by Alan Turing in 1950. So you need to remember, guys, that the year 1, of course, the year 1 is very important trial here. So you guys need to remember the year that is in 1950. The Turing test is like an integration game between the three players. There is an integrator who is a human. He has to integrate two players, one computer and one human. The integrator has to figure out which one is a computer by asking questions. The computer has to do its best to make itself hard to be distinct from the human. The machine will be the considered intelligent if it makes it hard to be distinct from the human. Consider the following scenario. Player A is a computer, player B is a human, and player C is a question answer. So integrator is aware that one of them is robot, but he needs to figure out which one. So all the player communicating with a keyboard and screen, the outcome is unaffected by machine capacity to transfer word to speech. Right. So I hope everybody is clear till here. Right. So these are the 3 points that is very important, I believe, about this. assessment used intelligence of machine learning. So you can say 4 point, let's say. So computer has to always do the best task to itself, and we try to get some distinctions between them and try to uh, get out some the best output from there. And that is going to be two important things for here. Exam results determined not by the number of correct answer, yes, but by the how closely the response resemble those of a human. The computer is permitted to do whatever it can to force the interrogator to make a false identification. Integrator multiply two number, right? So let's say such as this much player A after a long delay he gives the incorrect answer. If integrator is unable to distinguish between the machine and human in this game, the what is the answer, then the computer passes the test. The machine is said to be incapable of thinking like a human. This game is popularly called the imitation game. What is the computer vision in AI? Computer vision is basically nothing but computer vision in the field of AI enables computer system to deduce the meaningful interpretation from the image or any other virtual simulation. So you can say like pattern recognition in nowadays is very popular, right? Computer vision algorithm. You can say like computer pattern vision is the foundation of computer vision. Between the computer on a vast amount of data, images are posted and things are labeled and pattern are found in those items, right? So I hope everybody is clear till here, right? Produce a model flower at the end of the process. As a result, every time we analyze them and find the trying to we are trying to find the pattern, right, at the end of the process. Result, every time we submit the photograph, the computer will able to precisely recognize whether a certain image is flower. Computer vision is can be witnessed in many case area of life, right? For example, content organization in Apple Photo, facial recognition system, self-driving car, augmented reality uses computer vision. What are the Bayesian networks? A Bayesian network is a probabilistic graphical method based on a set of variables and their dependency present in the form of a cyclic graph. So Bayesian networks are the based on probability distribution, and they can predict the outcomes and detect anomaly using probability theory. This is the most important point in anomalies, right? Because that is used in Abbey bias. So used to perform tasks like a prediction, detection, anomaly, reasoning, gaining insight, non-stick, decision making. A Bayesian network, you can also say, uh, for example, could be used to illustrate the probability between the disease and symptoms, right? We can find out some correlation. Network may be used to calculate the chances of certain disease being present based on symptoms. Okay. What are the reinforcement learning? How this is the very like advanced AI, you can say, which was on the reward models, right? Like negative feedback is part of the machine, we does that. So it's encouraged. Learning because there is no label data, and agent must rely on its own experience to learn, right? So regulation is used to tackle a certain sort of problem in which sequential decision making is required, and the aim is long term, such as game playing, robotics, and so on. Agent interacts and explore the world on its own. In the reinforcement learning, an agent's primary goal is to increase the performance. The agent learns through trial and error as an result of its experience. It improves its ability to complete the task, right? It can be the best understood by taking an example of dog. When an owner of dog wants to cultivate a good habit of his dog, he will train his dog to do that. Things will the poor of a trait, right? A dog will be rewarded with the treat if he obeys his owner. If he is obey the owner will use a negative reinforcement technique by not giving his dog his favorite treat. This way, the dog will associate the habit with the treat. This is precisely how reinforcement learning works in machine. State, action, rewards, walking, sitting, right? What you can say, applying reinforcement learning to dogs, typically awarding the dog with treats. Positive reinforcement can make the dog adopt to the good habits. Okay. Walking in the case quickly. How many types of agent are there in? Simple reflex agent, model based reflex agent, goal based agent, utility based agent. Yeah, like a tabling assessment problem. So basically, you want to reach to your goal, and like you will apply some kind of algorithm to get those things and to understand the like to reach quickly, right, safely so far. So what is the point is that like if you are like traveling, if you are going through the like a simple reflex agents, like simple reflex agents ignore the history of the environment and its section with the environment and it entirely current situation. So that is also learning agent. These kinds of agent can learn from their experiences. That's true. Explain Markov decision process. Markov decision process (MDP) is a mathematical approach for reinforcement learning. Markov's decision process is a mathematical framework used to solve problems where the outcome are partially random and partially controlled. So Markov decision process is just a mathematically approach. We have seen from the statistics one that how we are solving their number of problems to solve, and I would like to make a video series on that over. So agent is that entity that we are going to train. For example, a robot that is going to be trained to assist a cooking in an agent, right? Like in a cooking food, right? The surrounding all the agent are called environment. The kitchen is an environment. The case ever mentioned. We have the action that the robot can move left or right, right? It can pass an onion or chip, right? We can check the policy. The policy is running behind taking an action. Reward received by the agent. Value is potential for the future, right? So these are the diagram. You can check it, right? Simpler agent has to do some action task to start from initial state. While doing so, it receives reward because of action text. What do you understand by reward maximization? That is a very simple question. I think we can skip this question. Hidden Markov model. This is the hidden state. Everybody should understand this. And like we are trying to get some ZT plus one hidden Markov model, hidden Markov, hidden state. Okay, so what are the difference between parametric model and non-parametric model? Parametric model fix a number of parameters to build the model in machine learning. Parametric analysis is to test the group of means, right? It is applicable only for variables. Parametric model can be useful in variety of scenarios, but they function best when the version of each group is varied. Parametric models holds a strong assumption about the data. Examples: Naive Bayes model, logical regression, etc. Parametric can be useful in variety of scenarios, but they function best when the dispersion of each group is varied. Okay. So like in a case of probability wale case mein, like you can use the parametric. And non-parametric, non-parametric model fraction number of parameters. And non-parametric analysis test medians. Okay, it is applicable for both variable and attributes. Non-parametric method can perform well in a variety of conditions, but their performance is best when each group speed is equal. Okay. It holds fewer assumptions about data. Okay, so non-parametric, so we don't have any certain parameters, we don't have any knowledge about the data, like a KNN. So KNN is a supervised learning, right? And like it's a label data, but we are not uh, properly assuming. But here, like we have variable and we have attribute as well. So this is the scenario. What do you understand by hyperparameters? The naive Bayes model is containing the variables, right? And logical regression is also containing the variables. That's the point. How do you check the hyperparameters? Hyperparameters are the parameters that control the entire training process. These variables are adjustable and have a direct impact on how successfully a trained trains. They are declared beforehand model hyperparameters which cannot be fed while feeding the machine to the training set because they refer to the model selection task. An algorithm hyperparameter which have no effect on the model's performance but affect the speed and quality of the learning process. There are two types of hyperparameters. Selection of good hyperparameters is crucial for the training process. Activation function, alpha learning rate, hidden layers, number of epoch, number of branches in the decision tree are the sum of the example of hyperparameters. What is overfitting? Overfitting is a concept in data science when a point does not fit against its training model. When the training model is fed with data, there is a possibility that it might encounter some bias that cannot fit into the statistical model. This happens when the algorithm cannot perform accurately against unseen data. That is the case of Overfitting, right? Overfitting, some point do not these points. Some points do not fit in the line. These points are outliers. The techniques used to avoid overfitting. If we can detect overfitting at early stage, it will be very useful for our training model. There are several methods to handle the overfitting, like cross-validation method is there. Parameter sampling technique for evaluating machine learning model on a small sample of data. Remove feature, we can remove the unnecessary feature of the model to encompass the outliers. Early stop type of relation used in machine learning to minimize overfitting when use an iterative method like gradient descent to train a learner. Early stopping criteria specify how many iterations can be completed before the learner becomes overfit. Training with more data, we can train our model with more data to accommodate outliers. Regularization in machine learning regularization is a method to solve the overfitting problem by adding a penalty term with the first function. Ensembling learning refers to combining the prediction from two or more models. What is natural language processing? Natural language processing is a field of artificial intelligence concerned with the giving computer ability to understand and interact in the human language in a human scan. NLP combines rule-based modeling of human language with statistical machine learning and deep learning models. This makes a computer fully understand and comprehend human language in the form of voice or text. Bikes operated GPS system, speech to text systems, customer service, chatbots, etc. or use NLP. Okay. And language processing encompasses a wide range of methods for analyze human learning, including statistical and machine learning techniques, as well as rules well as algorithm approach because text and voice based as well as practical application diverse set of pressing limitations, right? Stemming, part of speech, tagging, language detection, semantic link identification are all of the NLP activities. You have probably done those manually previously if you have ever diagram sentences, right? In a school, NLP task in general break down the language into the comprehend the relation between them, and this task you are using high NLP can be like content categorization, topic discovery and modeling, sentimental analysis, speech to text, text to speech conversion. What is the difference between natural language processing and data mining? So text mining is a use to extract information from the text, while NLP is a method allow machine to understand, interpret, and create human. It employs a variety of tools, language to process data, and it process data and generate output using high-level machine models. Yeah. In comparison to NLP, we can readily measure the system performance and accuracy. In comparison to text mining, measuring the system performance is rather challenging in this case. What is fuzzy logic? This is the last question of our presentation. So the fuzzy logic is nothing but the fuzzy logic is a method of reasoning with artificial intelligence. That is simple human reasoning. According to this logic, the outcome can take any values between true and false, testily 0 and 1. For example, the outcome can be certainly yes, possibly yes, no, or certainly no. Conventional logic states that computer can take input and produce definite output, which is true or false, which is equivalent to one yes or no. Cold, warm, hot, 0.4, 0.6. Right? So visualize that come take any value of p. That's correct. And take input and produce a definite output, which is true or false, which is equivalent to human yes or no. Visual logic is a method of reasoning in abstraction that resembles human reasoning. This logic between true and false. For example, outcome can be certainly yes, probably yes, not sure. Outcomes include word frequency, correlation, pattern, and interpretation. The outcome includes semantic, syntactic, and grammatical structure. Human assistant is sometimes required. So these are the things that I think, guys, these are the very, very important points that everybody should understand this, and everybody should understand for their uh, like security to understand this because it's all related to mathematical concepts, right? So I will try to make a video on mathematics behind it, and I will try to certainly able to define some mathematics behind it and mathematics approach. So I will try to make a series on that. Please, guy, you can ping me if you want to see some mathematical concept behind it. Of course, we will try to uh, some kinds of logic like this. Thank you very much for your time.